All right, so I'm going to go over a bit of the wiring now. This isn't the final wiring setup because I've already made a change, as you'll see. So I've been doing a lot of research on the M-Tron. I think the M-Tron is the way to go. So I've done the first part of the pinout for the ECU. So this is based on the KV16. To be fair, I haven't actually looked at the other models to see if they've got the same inputs and outputs, because I don't obviously need to control, this controls 16 injectors. I don't need to control 16 injectors, but I do need a massive amount of inputs and outputs. So I'm just going to quickly run through these. As you can see, there's quite a lot, and anything that says NC is basically just not used. So yeah, so we've got, starting from the very top, this is like plug 1, plug 2, plug 3, or A in this case, B, C and D. But yeah, so some of these, obviously this is injector channel 9. I've only got 8 injectors, so it's going to be boost controller. So injector channels, boost controller, fuel pump control, cooling fan control, and then nothing. We've got a couple of grounds. That is literally it for that plug currently. Injectors, we've got, what have we got? All 8 injectors, primary and secondary. We've got VTC solenoid on auxiliary output 1, VTEC switch, the throttle plus and minus, ignition coils. Obviously they're going to be on the ignition channels, only 4 coils. Same few grounds going on. Obviously this is just for the pinouts, not how it's going to be wired, obviously. So analog channels, obviously they're all fairly high speed channels, so you want to put your temperature sensors, your pressure sensors, and in this case your throttle position sensor. So you can see there that you've got throttle position main, because this is a drive-by-wire. You've got throttle position main, throttle position sub, and then accelerator pedal position main and sub. So they take up 4 of the channels, which is quite annoying. And then obviously, sorry, just going back, these throttle servo, they're actually the things controlling the throttle body itself, and they need to be on half bridge outputs. Obviously these are all inputs from the component to the ECU. On the next page, this is where it starts to get a bit tight, and in fact I think I'm probably going to have to start using the PDU or PDM as an input for some sensors, and then put it on the CAN bus back to the ECU. Depends on what the sensor's used for. Obviously there's critical and then, you know, not so critical sensors, but other input channels, obviously coolant temp, inlet temp, engine oil temp, fuel temp, because they're all, well, fuel temp is needed for the basically part of the calibration. Obviously as fuel temperature changes, the density changes, and that changes your pulse width required by your injector. Compressor, outlet temp and inlet temp. Oh, okay, cool. I don't need to change that round. Ha, okay, yeah, sweet. So I did think that I didn't put in, of course it's compressor. Okay, yeah, all good there. So ignore that correction there, that's not needed. So yeah, compressor outlet temp, compressor inlet temp. That's going to give me the temperature ratio between inlet and out, so how efficient the turbo is working. Engine oil pressure, coolant pressure, fuel pressure, sensor ground, crankcase pressure. I'm not 100% on that one. I did actually move that to digital input, which you can do, but you lose some resolution. So auxiliary inputs are really fine reading. Obviously if you're trying to put a temperature sensor or press it, anything that's voltage based, if you're trying to put that in the ECU, you do it on an analog input, because they've got the highest frequency reading, basically, well, if you can call it that. But once you start putting things into digital inputs, they don't read the resolution quite so well. So that's why I started, I think I did put a couple, oh yeah, so pre-turbo map and post-turbo map sensor. So that will literally be on the inlet and on the outlet before the intercooler. They're going to go on digital inputs. Now these digital inputs I think it's 1 to 6 or something like that, is actually pretty high frequency. It's a pretty good resolution for voltage, and that's why I did swap this around, because I thought I didn't have pre-intercooler air temp, but I have, so that's actually really good news. So whether it will change much from this, maybe a couple of maybe you know, like the pins might move around or something, but generally speaking, this is basically going to be it now. So yeah, crankcase pressure. Now that's going to have to really go down on the pressure outlet from the block over here, unless I can find somewhere else, or I do it from the front cover, which is just there, because obviously if I start running lines out into a catch can, it's not, the signal's going to be terrible. So I'm not 100% sure about that sensor anyway, but if obviously we've got the wiring, which either way is going to go underneath the manifold over here, it's there, isn't it? Sensor ground, just ECU ground. Yeah, then obviously we've got, that's the input for the VVT, turbo shaft speed, ethanol content, which is another digital input. Then we've got the two pressure sensors. There'll be, I think I'm looking at the Bosch combined pressure and temperature sensor. And they'll have little mounting tags on them, like as in little mounting boss. I think they might be the way to go, because they're combined and they're very good. And obviously I'm going to be under 3 bar anyway, or under 2 bar of boost anyway. So, and they're not critical, i.e. the ECU isn't going to use them for any fuel calculations. That's for me to know the pressure ratio through the turbo, how efficient the turbo is operating, and then how efficient the intercooler is operating. Because if you've got pre-boost or pre-pressure, pre-temperature, post-temperature, post-pressure, you can know how efficient the intercooler is as well. So they're going to go on a much slower, well, I say much slower, it's slightly slower than the other analog inputs. What else we got? Obviously digital inputs for wheel speed sensors. This doesn't come with wheel speed sensors, so I'm going to have to fabricate something on the wheels or the drive shafts. The drive shafts may be a bit hard because they're up and down. Might be able to put it on the inside of the drive shaft itself, like on the actual Burford joint, you know, what it is, a Burfield joint, like a UJ. So yeah, I've still got to figure that out. If I move over to a 350Z diff, obviously that's got a pair of sensors in it, but they obviously weigh twice the amount as this current diff, so that's an aspect and a half. So then I'm going to have 12 volts from the PMU, 12 volts from the PMU. Yeah, so that's going to be the main supply somewhere here. Yeah, main supply, the top one for the ECU, and then this is going to be auxiliary supplies. So the way this ECU works is, I mean, it's the same as every ECU, but they have a main supply for the ECU, and then auxiliary output 13 to 16 gets power directly from one pin, and another one down here, auxiliary outputs 9 to 12. Obviously, that's to power your throttle bodies and stuff like that. And then sensor outputs actually comes from, like, sensor supplies are down here and they come from something different pin. So yeah, then we've got crank sensor input and exhaust sensor input, and then somewhere here, where is, oh yeah, sorry, that's the engine position inlet hall VVT. Yeah, so that's your two main engine position sensors, and obviously they need to know where the VVT is, so we can obviously work out what the numbers actually are. Crank sensors and 2 amp fuse. What's that? 2 amp fuse, power from isolator, EC control. Oh right, yeah. So that's basically an input switch. So I want the ECU to control the PMU, so the PMU doesn't switch off before the ECU tells it to, basically. 12 volt from PMU, what's that? Oh, that's auxiliary outputs again. 5 volt sensors, their outputs, not inputs. And then the Ethernet cables. And then I have got a whole bunch of other stuff here, which is, that's just telling me how to control the PMU. So I'm looking at the ECU master, PMU 16, I think it is. I'll probably get it with data logging. Otherwise I'll have to I don't even know if you could output the information as CAN and then log it on the ECU. I don't know if you could even do that. But I'll probably get it with login so I can obviously make sure what's going on and everything. If something does trip, then I can go back and look at it. So I've still got clutch switch, reverse switch, neutral switch. Now, I don't know if this gearbox even has half of this stuff. I can't even remember. GPS, G-meter, brake pressure, shock pots. We're not going to worry too much about them at the current state. But and EGTs, they're all going to be CAN-based anyway. Same as all the widebands. So I'm going to go, I'm pretty sure, unless M-Tron say something very different when I talk to their technical, I'm pretty sure that I'm going to be going for the Cyvex 8 times lambda to CAN with a pair of pressure sensors in it, and then it comes out obviously as a CAN signal, so the pressure sensor compensation is done pre-output calculation basically. It's a much better way to do it. So they're obviously all going to be in there. Then I've got nowhere to put EGTs, so that is another thing to think about. I've just realized I don't have my EMAPs on here. Yes, that's why, because the EMAPs are going to come from the Cyvex. So yeah, I'm going to have one in one of the tubes and then one in the collector. I am going to have one on the output side of the turbo to see what the pressure is in the downpipe. So, and the Cyvex only comes with 2 pressure sensors. So somewhere here, we have got to put in an EMAP. Did I not put that in? Map. That's pre-throttle body, post-throttle body, compressor outlet, coolant temperature. Okay, yeah, so we probably will be getting rid of crankcase because crankcase is actually on, well, I suppose I could put it on, crankcase is going to need to read much faster than one of the digital inputs. I'll have to see what these digital inputs actually do, like as in the speed, because all of these are taken now. So yeah, I'm going to have one EMAP, probably on a digital input, which might be this one now, where I've said before it was swapping. So yeah, I probably won't swap crankcase if I use it, but I do need to put that EMAP in there, which is going to be post turbo downpipe, or whatever you want to call it. So yeah, that's that. I'll probably put a link to these somewhere. But like I say, they're probably going to be edited, but I just need to obviously note down that absolutely everything that's going to be on here, because I want to start making the Loom up, and I don't really need the ECU to do that, as long as I know where the rough position of all the parts are. Right, so what I've done is I've basically just gone round and placed a few things where they should be. List over there, I have forgotten a couple of things already, and something I don't know about is where the coils are going to go yet, so something. Water pump is one thing. This needs to be pulse width modulated, and because of the way and the power and this is going to be used, they're pretty hard on components. So if you have a PMU or an ECU, it has to have a flyback diode in it to control this properly without overheating. I know the ECU master stuff has a couple of flyback diodes. I'm not sure, or maybe it doesn't have. I can't remember. I'd have to look at the actual settings. It's going to be controlled by the PMU, so we need to make sure that this is going to be, stay decently cool. Well, the PMU is going to stay cool. We don't overheat it. So I have to think about a flyback diode for this, but I haven't actually included that on this list. Maybe it's because it's on the other list. I'll find out. Right, so this is the other part. Goes on the back of the K20 head. And that's going to have a dual sensor, so pressure and temperature on the back side or underside. and it's going to be a Bosch dual sensor. Obviously, I've heard all the stuff about Bosch sensors leaking and stuff like that. I've not actually personally had one leak, and I fitted a few. I wonder whether the ones that are leaking are fake or real. I wouldn't like to say 100%, but if it does cause a problem, I'm basically going to get some Slytech ones. They do a dual sensor. I think they do 2 different versions, 4 bar and 10 bar. So that'll be better because it'll be higher resolution if it's 4 bar. In fact, for all of them, I've got the Bosch sensors already, so potentially I could just get different adapters. So that's an M10 by 1 adapter on the bottom there. But if I got a Slytech one there, 1/8 MBT, so all I'd have to do is replace that ORB adapter, and then I could just put that in there, change the calibration, job done. I think the sensor's slightly narrower, slightly longer, but they're apparently reliable as can be. They're also a little bit more money, but yeah, so obviously got these 2 in now, so I can do the wiring to them. But by placing these in here, obviously it gives me an idea. Obviously it's not going there, it's going down the side, but you know what I mean. It just makes sure I remember them. Coil wise, I'm going to use the IGN A1 coils. Yes, I could go with stick coils, but those A1 coils or the IGN coils, they're just a better coil. They've got loads of output, and I don't want that to be any kind of limiting factor. You can have partial misfires at rich mixtures and stuff like that. So it's not a case of if it goes off and you're good and we're done. You can get partial misfires, and I don't want that. So that should eliminate the whole thing if you're using one of them coils. Their outputs more than that of the Hitachi R35 ones. They're just the best coil at the minute, basically. And especially when you're running on ethanol, it just gives you that bit of safety. So whether they're mounted across the top plate here at the back, obviously that outlet won't be there for the breather. I could mount them across here and then run lines out, or what I'm thinking of doing is actually having a plate run across here and then mount them across here. They won't get any heat to them really because, like I say, I'm going to put a shield in. But yeah, if I mount them across here, so all I'm going to have to do is basically measure to here, and then I have an add piece that can then go, okay, yeah, this is actually going to be mounted here. We'll move the coils. And as I say, the coils are going to be on a separate loom anyway. So potentially I'm just going to have the breakout somewhere here, and then it'll go to these ones, or it'll come across out. Same as the injectors. The injectors are going to be a breakout loom. Yeah, so I'm sure I'm going to think of something else. I've just put the turbo speed sensor down there. Again, because it's got the wiring, I'm not going to break into that. It should be 3 wires. I'm hoping that is going to be I'll have to have a look at the wiring for that, actually. I can't remember if that's a shielded wire. It should be. But one of them will be the shield. But yeah, we'll see. I'll just check the wiring on that. But yeah, if I can get those things in there, then obviously I'm not going to forget in any way, shape or form. Alright, so I'm literally going to use an old extension lead, and it's literally just, standard 3-core extension lead cable. But this one's broken, so I'm basically just going to start running it through where I want these wire systems to come out. As I say, I'm pretty sure that I'm actually going to run these breakout looms for the ignition and the fuel system from the ECU. They're not going to be breakout looms later on. So I'm probably going to run like this side of the loom from here, breakout from that side, because I've got multiple holes which I might as well use. Right, so the way I've decided to do it is going to be, I'm going to have a mini loom coming out to these 2 sensors, and then the other looms are basically going to come from under manifold, above manifold. So this one's going to be the one with the majority of the stuff, I would imagine, as that's going to come under here. It's going to have the knock sensor. In fact, it's not going to have that much stuff either. It's going to go underneath the manifold. It's going to have the knock sensor, the throttle body, the water pump, the pre-turbo pressure sensor. I think that is it. I'll go through the list. But this is exactly why I'm running through this now, because you need to go over this stuff multiple times. So I need to re-go over all the lists that I've got and double check that all the output is correct. Obviously, I haven't laminated these aren't, you know, permanent. So yeah, I mean, I already made one change at the beginning, but so yeah, I'm going to basically, all I've done is I'm basically saying that that is the point of the bulkhead, and I've given myself a little bit extra. So this one's going to go down to the dual pressure and temperature sensor, and this one, obviously it's not going to be this thick. This one will go to the, it'll be a digital output, and it will go to the, or digital input actually, and it will go to the ethanol content sensor. So that one's done. And like I say, I've left a bit on there, but it's you know, it's a fairly straightforward thing. Whether I have to add stuff or not later is exactly why we're doing this like this. Right, so a couple of quick additions. The temperature and pressure sensors are going to be the Bosch 4-bar, Bosch 3-bar T-map sensors, and they basically come with a little mounting boss, and then basically I'm going to put one in there, and I'm going to put one probably on the top here because it's a nice flat surface with plenty of space. Everywhere else is curved, and although you can buy sensor bosses that are curved, they're just a pain in the bum to weld in. So I think if I put it up the top here and on the side over here, could be there, probably a bit easier to put it there maybe. Yeah, that makes more sense. So yeah, I think that is what we're going to do with them. So I'll update the list with what sensor is going in there. So it will be the Bosch 3-bar T-map. Now, obviously, they only read up to 2 bar of boost. This engine is never going to go above 2 bar of boost, ever. So, well, I assume it never will. Hopefully it never will. The boost cuts will cut in and save its arse. All right, so we have T-map down there for pressure and temperature for the outlet of the intercooler. We have water pump control. I added this one in, fan control. Obviously it's on the ECU, but I forgot to put it on the actual Loom for most of that. Throttle body, and then we've got down here alternator, knock sensor, which is going to fly around. Across the front, we're going to VTC and VTEC, and we've also got the, which is going to loop round to under here, the pressure and temperature for the coolant. I think that is it on that cable. Separate line with a main power cable going to the starter motor, and it's going to run the starter solenoid cable through it, so they're not going to be near any of the sensitive stuff. Okay, so on this side, I think I've got everything. I hope I've got everything. Brake pressure is going to be inside, so I don't need to worry about that. Clutch switch is inside. Yeah, I'm pretty sure I've got everything. So up the back there, we've got 2 cam sensors, which will be taken off of the original temperature sensor there, which won't be used. Then it's going to run down along the bottom of the block to stay away from the manifold, under the engine mount. Then come basically up to here. We're going to have crank sensor, oil pressure and oil temperature, either this side or the other side, and then crankcase pressure here. I'm going to put one of them, hopefully, we'll have to see what the specifications say, but ideally a side mount sensor, instead of coming, you know, having a sensor come straight out and then being plugged onto, because that's going to bring it way far out. But yeah, if we can get a side mount one with a pressure sensor in there, that would be awesome, because I've got an alley cover for this. So hopefully the alley cover, I can weld on the standard sort of Bosch pressure sensor. Then we're going to come along under here, go along. It's going to be floating. I kind of thought about going along the sort of the lower subframe and stuff, but I'm just going to make it float. So it's going to come across to here. It's going to actually break up into multiple parts. So we've got boost control, turbo speed, T-map for the intake pipe, which will obviously be an alley intake pipe most likely, come around like that, and then we'll have a pressure sensor and a temperature sensor in it. And then the last one, which is going to run up to the top here, which will be that other T-map, which will be pressure and temperature after the turbo compressor. I think that is that side done. So the only thing to do now is going to be injectors and coils. Right, so here are my two leads. This one being the right hand side, and that one's the left hand side. The only thing I may slightly adjust is some of the transitions. Obviously, the fewer amount of transitions I can have, the better. So where this one here is transitioned, oh no, that's the VTC, so I definitely do want that to break out at the last minute. So that's fine, because I could have taken this VTC back to here and run the pair together. So there isn't that many transitions. But the only other option, I guess I could have run these to here and then run them out this way instead. So they'd have done a bit of a U-bend, but I don't really like that. Yeah, no, I don't think I've done too badly there, actually. Yeah, no, I don't think I've done too badly. So there's the two looms, one per side, and then, yeah, like I say, coil and injectors. I think I might do the injector looms out of something a little bit smaller, because this is hard to manipulate. We'll see. All right, so I'm about to do the coil, injector wires. I've got this slightly thinner, real cheap power cable. It's got the thickest insulation on it ever, but anyway. And then I'll use this for the main trunk, and then I'll come off with each bit. That seems to be the best idea I can come up with, without obviously wasting real resources on this. Right, and here's that loom finished off. So you've got top injectors, bottom injectors. That's my mark for the bulkhead. So that'll be a separate loom with a plug on it. So then if I change the injectors or something like that, I can just, you know, unplug that loom, put a new one in. So I've got to do the same for the coils, but I'll do that once the coils arrive. So I've had a few bits turn up in the post. I've made some changes to the wiring loom. You saw me obviously mock up some bits and bobs. One consideration when I was sitting down looking at the Excel spreadsheet that I've got, obviously down here I'm going to have map sensor and temperature sensor. Then I'm going to have the water pump here. The wiring's going to go up here. Well, water pump's going to be pulse width modulated. So potentially I could run it in the loom. So basically when you pulse width modulate something, you actually get quite big like RF, like frequencies off of the wiring, obviously as it's turning it on and off. That's why, like on most ECUs or most control units, you need to put a flyback diode to just deal with that large spike of power, basically. So the water pump is the only thing that's really got some decent amps going through it, like, you know, 10 or so, 12 amps. But obviously when you instantly switch it on and off, there's like a high current load, basically. You can soft start things, but we're switching it on and off very fast. Well, I think, I'm sure it's like 150 hertz or something like that. But either way, that causes a lot of interference for other components. And I've recently just dealt with an issue where someone had their TPS dropping out when their water pump turned on. So, having seen someone else do that, and this was in a very expensive DR25 twisted concentrically loom, blah, 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 whatever. So yeah, I've now seen that the water pump can have a major issue. So I think the best way to do this is going to be actually to run a separate loom to the water pump, and I couldn't, for cost effectively wise, if you like, I couldn't find a 2-core shielded big enough or a 4-core shielded big enough. So what I'm actually going to do is run out the PMU or distribute unit, whatever you want to call it. I'm going to probably run 4 pins to control the power. Or should I say 2 power pins to control the power, because I don't think there's going to be enough output, and I don't want to stress one pin in any way. So I think I'm going to run 2, even though they can deal with 25 amps. Like I say, it's PWM, so there's a lot of other stuff going on there. you should really run it through 2 pins. So that's what I'm going to do. And they're going to run through the front here, and then I'm going to run a power cable back, and that's all going to be shielded. So I've bought some T connectivity shielding braid, which I'll run these cables through. They won't be shielded this end, obviously. They'll be shielded next to the PMU. But yeah, that's obviously a slight change to this wiring loom. So basically I can cut out the bit for the water pump system, but the rest of it should be fine. Fans are fine because it's just on or off. If you just wanted to turn your water pump on and then off just simply, then you wouldn't need that. It would just be a power line. You know, you might get a sudden spike frequency, but again, the PMUs and PDMs and whatever you want to call them, they normally have soft starts in them, so you can ramp that power up anyway. But you know, it's not going to cause really too much interference. It's PWM stuff, so pulse width modulated. So that's the one change that I've done there. So it's a few weeks later. The pinouts changed slightly. This is new printouts. And I've just 3D printed this. This is their PDU from ECU Master. The pinouts changed a chunk because what I'm trying to do is get stuff out of the ECU just to make sure that I don't basically fill it with stuff that is not really necessary for the calculations that it's doing. So some of the pre-turbo map and pressure probably won't be going into the ECU. If it does, it will go via CAN, I would imagine. Whether it will stay like that, because I need to finalize, you know, what we're trying to do. But stuff like that is for me to work out how efficient the turbo is. Really all I need for the ECU is temperature. We don't even need temperature, but I want temperature and map pressure before the throttle body and after the throttle body. So I've moved some things away. So this isn't just the ECU anymore. Let me get these laid out. Right, so I'm not going to obviously go over this fully, but like I say, I've moved some away from the ECU. So this is the ECU. This is the keypad, CAN keypad, the dash, then the PMU, and then we've got the battery isolator, a GPS unit, and the lambda CAN. So this will be in the description of the video, so you can literally go and have a look at all of this, and you can pick it apart if you want to. So what we've moved across, we've got like pre-turbo temp, post-turbo temp, and then pre-turbo map, post-turbo map, crankcase pressure, what's that, post-turbo back pressure, oh yeah, that's for the exhaust, sorry. Turbo speed is now not going into the ECU, ethanol content's not going into the ECU. Let's have a look what we got. This is all PDM stuff. Yeah, well, it is PDM, but PMU as far as ECU Master's concerned. I think that's about it. So I have got some free slots. So for instance, there's some analog inputs, analog signal input there. I don't know what it is, if it's temperature based. I haven't put what it is, but basically there's a couple of free inputs on the PMU. There's a couple on the, is there a couple on the Cyvex? Not on that. There's a couple on the Cyvex GPS and G-sensor system, which is maybe more future than current, but obviously I want to make sure it's in there and pinned out correctly. But there is a couple of inputs for temperature and stuff on there. But ECU wise, I'm just trying to take out as much as I can because I don't want it doing more than it needs to. And bear in mind, when I say that, it's already filled up. Just trying to keep the main stuff inside the ECU, make the ECU do as little as possible. And that means that, you know, like any computer, it can not get bogged down by doing silly stuff. This little bad boy here will basically be, so layout purposes, I'm hoping to get hold of the rest so I can start printing everything up, so I can have everything from ECU Master's got almost a printable like setup. You have to go into like SolidWorks and change it all up so it's usable, but nonetheless you can get it printed. So I've got that file now. Wiring wise, we need to do some changes because one, I'm moving where the map and pressure sensors, so I'm not going to use the Bosch T-map sensors with the weld on plates. You'd have to like weld on a little plate here and then have a sensor come off, and they're really nice units, but I can just see it being more problems than I need. What I've decided to do is simply use the Slytech stuff, and I'm going to basically there'll be a system in here to come up to get post throttle body pressure and temperature. I think there is actually a block on the bottom somewhere. See if I can feel it. Yeah, so there's 2 ports underneath. There's a 1 port. Oh no, 2 ports. 3 ports. Yeah, so underneath there's 3 ports which I'll probably use. And interestingly, I haven't put the wiring in as well. I missed the after throttle body wiring for TPS and map, so that's got to go in. I couldn't see it, so I've obviously missed it out, and this is why we do all this stuff. But the throttle body and the fan and everything like that's okay, so it's really just the water pump control. So I need to shrink up the pre-throttle body pressure and temperature sensor. I'm moving over to the Slytech, which is actually probably going to go inside, outside, inside here, because the shielding for the rad, so the ducting for the rad's going to go on the outside, so it'll be on the inside. Maybe here, because that's a fairly flat surface there. We'll put in a Boss, then I'll put a sensor in, and then the wiring. And it's the Slytech, I think it's a 5-bar, high-speed temp and standard map sensor, all in one unit. The water pump wiring needs to absolutely come out completely and be on its own. So I'm using, if we have a look here, so where are we? Where are we? Here we go. PMU. I'm going to use 2 pins, so pin 13 and 14, but they're on opposite sides of the plug. I haven't got the plug printouts. When you have a look, if anyone ever actually looks at this file, you'll be able to see that I've got on page 2, there's all the pinouts for every sensor. I don't think the main component pinouts are there, because obviously they're here. But if you have a look, these 4 and 14 are actually opposite sides of the plug, which means inside the unit you can keep transistor heat down instead of putting it all at one. The pins, use the pins on one side. The transistors are very close. If you use opposite sides, the transistors are further away. Obviously we're going to be using a flyback diode anyway to try and keep the voltage spikes way down, but I've put 2 water pump wires in, and the reason is basically transistors. So although the ampage can be taken up, no problem, we're not going to even use 25 amps to power the water pump, the transistor heat is going to be the issue. So from everything that I've sort of read about the setup, we need to run 2 sets of control wires to the water pump. So this is that braid that I'm talking about, and that's just going to go over the wires basically that feed to the water pump. The PMU is high side powered, so that's powered, well, it's PWM controlling with the live side, and then the water pump will be earthed. I was going to earth to the chassis down here, like have an earth point, but actually what I'm going to do is I'm going to run that earth all the way back through the braid, and I'll run it to an earth point inside, assuming I can get the cables through this, because both of those wires that are coming out of the PMU should be fine in 18 gauge, but I do need to put in the map sensor and temperature sensor. Whether I run these individually, at the minute they're done as one sensor, and they're done as the Slytech dual sensor with the fast acting temp. The sensor itself, so I've just got this gauge here, the sensor from the end of the 1/8 MPT only comes out about another 5 mil-ish. So the pressure sensor's in the actual main housing of the thread basically, and then the temperature sensors sort of thermally, what would be the word, insulated basically against the body. Now heat soak really isn't going to be that much of an issue. it's a race engine. Obviously I don't want it, but at the same time, the only other option is for me to mount the temperature sensor with a extended tip right down inside, and then I can run the map sensor externally, I guess, if I really wanted to. I don't know what the failure rate on these from vibration is, but you know, most sensors are mounted inside the flipping thingy, and we're not solid mounted, we're rubber mounted, so hopefully it won't be too much of an issue. I can always try it, and then if I need to rewire it, and then I can do it as a separate you know, separate set of wires. Like I say, this isn't the very final loom that will be built. The only other problem I've got is that the dual sensor is 51 millimeters long to the end of the plug, which is going to put that out here. So I don't even know if that's that is 1/8 MPT. But that's going to put that plug out there, and if I you can see that is potentially going to be quite far out. I don't know exactly. It might just be the engine bay, in the engine bay, and I don't know what the sort of hood clearance will be, or bonnet clearance, but then you've got an additional plug on that, which is going to be up to 70 mil. So we're starting to push the realms of how long this sensor can be. There is a plug on the bottom. In fact, that's why I got that little gauge out. There is, I think, 2 MPT, 1/8 MPT plugs on the bottom. Problem is that then mounts the sensor upside down, which means it's more likely to get any crap in it. So if we do have, well, I suppose if we have a failure, it's fucking sensor, innit? But if for instance anything goes through the inlet that could be moisture based, you're going to have the pressure sensor facing upwards, which then maybe not the ideal situation. Either way though, if I make the wiring long enough that I can get to both, then I can have that choice, can't I? I think that was about it, wiring wise. Same the other side though as well. I'm going to use the Slytech sensor. We'll have a boss. I'm not sure where I'll put it yet. It might even go somewhere down here along this side, because the bosses that I'm using are just your standard round 1/8 MPT style units. I don't need a flat surface really. I can just, you know, drill a hole and put it straight in. So I'll probably mount that sort of there-ish, and then it'll give me some clearance to get some wiring out to it. I think that was about it. So it was really just because of this water pump having so much RF coming out of it that we need to obviously separate it from the whole system, so we get rid of as much of it as we can. I don't want any problems later down the line. Now I've seen it cause a problem, definitely don't want a problem, you know. That's just knowing something and then not doing anything about it is pretty stupid. And yeah, would have been good if I'd have put the map sensor and temperature sensor on there. I can't see it. I'll have a quick look because I did just throw the wiring through. But yeah, so I'll get these cut back. All right, so I just completed that little bit, cut that down basically, and cut off the water pump part. And then I've rerun the water pump cable basically, if it'll focus, through the lower bulkhead hole. It'll run along the chassis rail. Obviously this exhaust won't be a problem because this is all going to be sleeved, and obviously it's going to cut down way early from there. It's pretty hard to see on the camera, but, and then it just runs all the way up. I've also just linked in the starter motor wire, and then, well, it'll be the main power cable and the like the starter solenoid. Post throttle body, air temperature and map sensor, and I've left it long just to make sure wherever I go. As I say, I'm going to pre-build this loom without any sheathing. Basically it will just be taped together, as in, you know, just bunches of wires taped together again, pretty much, all long, and then I'll just refine the install once we're a lot closer to where we need to be, because I'm still missing some of the sensors and stuff like that. So once all that comes through, then I can start to really finalize things. But this will get me 99% there, I think, now. So I think that's basically it mock-up wise. The only other thing I need to think about is the Cyvex coming through. Actually I have got to do one wideband in the outlet here, so I will add that to the VTC and what's his name. So yeah, one wideband will be here. Yeah, so if you want to have a look over that, tell me what I've done wrong, that'd be great. And then yeah, anything else you can see that I might need to add in. Obviously I don't need 90% of this stuff to run an engine and run it reliably pretty much, but this is not what this is about. This is
data and yeah, just trying to do everything I can to know everything I can.